Hi folks, today we're going to be looking at everyone's favorite type of higher exam question, optimization. Now, a lot of people have issues with optimization because there's quite a bit of problem solving involved and people tend not to know where to start. So what we're going to do is have a look at this specific question, look at some techniques that you can use to help you do other optimization questions. Now, if anyone's not too sure about differentiation, the process itself, then please have a look at some of my other videos where I talk about differentiation and how to actually do it in stationary points and all that good stuff. So let's have a look at this question. A zookeeper wants to fence off 6 individual animal pens. Now, fair enough, yeah, we can see the 6 pens. Now, each pen is a rectangle measuring X meters, fair enough, by Y meters, as shown in the diagram. A, express the total length of fencing in terms of X and Y, so really the perimeter. They want us to kind of find an expression, a formula, an equation that would express it in terms of X and Y. Okay, so we'll have a look at this. I'll move that there. Okay, right, let's do this. Okay, so this is A, part 1. Well, it's the perimeter, isn't it? And we want, so you've got X. Okay, well, how many X's do I actually have? 1, 2, 3, 4, 5, 6, 7, 8. Well, it will be as simple as 8X plus how many Y's? 1, 2, 3, 4, 5, 6, 7, 8, 9Y. And that's pretty much it. That's all they're looking for. That's A, part 1 done. Part 2. Given that the total length of fencing is 360 meters, right, so they're telling us the perimeter is actually 360 meters, show that the total area? Right, so they've gone from talking about perimeter, which is one variable, to talking about area, which is something completely different. And that throws a lot of people off. They're like, hang on, how do I, go from talking about length and perimeter to talking about area? And, I'll show you about this. So, the area of the 6 pens is given by this. Now, what you should really do is look at what they're asking you to prove or show or find. And you'll notice, we all know that area of a rectangle is length times breadth, which in this case would be the x's times the y's, but there are no y's in the expression that they want you to find. Hence, you have to find a way to replace the y's, and that's where the perimeter comes into play. So let's jump back to the perimeter for a second. We'll look at this and then jump to area. So we know the perimeter is 360, and we know that it's 8x plus 9y. So why don't we just go ahead and make 360 equal to 8x plus 9y. Now, a lot of people will say, well, I don't know where to go from here. So we'll stop here and move on to area, and let's just have a look. So we know area, like I said, is length times breadth because it is a rectangle, and obviously if it was a different shape you would adjust the formula accordingly to what you're trying to find. So the length of this rectangle is, well, 2x, I guess, times breadth would be 3y, because that is only 1, so we need to have 3y. And again, like I said, because there is no y in this place, we need to find a way to get rid of the y's. Well, that's where the perimeter comes in. Now, I have a 9y, not 3y, but how about I rewrite this for 9y first? So let's take the 8x over. That'll be 360 subtract 8x equals my 9y, and then divide through by 3, and that'll give me 3y. So 360 divided by 3 is 120. 8 divided by 3, well, that'll just be 8/3. Word of caution, don't use a calculator and end up with a decimal, or even if you do use a calculator, don't write it as a decimal. It'll make your life infinitely more difficult. So fractions are the way to go here. So now that we have an expression for 3y, let's go ahead and sub this in place of that 3y there. So a of x equals 2x multiplied by what we have 3y to be, which is 120, take away 8/3 x. Okay, let's go ahead and multiply that out. And I'm looking at this 8/3 and looking at this has got a third in it as well. It's kind of making me think I'm doing the right thing. So 2x times 120, well, that's 240x, and 2x times minus 8/3 x, well, that's simple. It's just, fraction. That's 2 over 1. 2 over 1 times negative 8/3. You multiply the top two numbers together, 2 times the negative 8 gives me negative 16, and the over 1 part, and you can think of it like that, the 1 times the 3, well, that'll just give me 3, the x times the x will give me x squared, and that is exactly what they're looking for, as required. Oops. Excellent. Okay, so pretty straightforward, and this is the part that tends to cause people the most difficulty. And what you'll notice is when I took the perimeter, the information they had given me, and used that to replace something in the formula they were asking me to find, that's a very common idea. You tend to do that in the majority of optimization questions, so always look out for that. Anyway, let's move on. Part B is asking us to find the values of x and y which give the maximum area, and then let's go ahead and write down this maximum area. Now, well, for those who don't know, differentiation, you tend to generally, well, in optimization anyway, find either the maximum turning point or the minimum turning point. So that's what we'll be doing here. So let's have a look at this part B. Slide this up a tad. Okay, so we'll start with the equation they've given us. Now, for anyone who's unable to actually do part A itself, you can just start from part B. And then, if you want, later go on, after you've done the rest of the exam, come back and try and do part A, which a lot of people do. So let's differentiate this. So that'll be A dashed x will give me, differentiating 240x will give me 240. Differentiating 16 thirds x squared will give me 32 thirds x. And again, for anyone who's not too sure about the differentiation process itself, please feel free to watch one of my other videos where I show you how to differentiate. One thing we do need to say, we need to make a little statement here. In higher, we actually gain a mark, or we don't lose a mark as long as we make this statement. So for stationary points, turning points, A dashed x equals 0. So what we're effectively saying is that the gradient, or the differential, is 0 because the gradient of any stationary point is in fact 0. So let's replace that with 0 equals 240 minus 32 thirds x. Let's solve for x now the way we traditionally do. Take the negative 32 thirds over, gives us positive 32 thirds x equals 240, and therefore x will equal, take this over, will be 3 over 32 times the 240, x in fact equals 22.5. Okay, and yes, I did use a calculator for that because my arithmetic skills are not the best. Okay, great, so we have a value for x, and this will be in meters because the question itself, you'll notice, is actually in meters. Okay, fair enough. What do we do now? Well, this is where we do a nature table. Now, I know some teachers prefer you to differentiate again to show that it is actually rising, but the SQA prefer it if you actually do a nature table. So how should the nature table look? Well, nature table effectively would just look like you have your x, you have your A dashed x, and then you have your shape, and then you have a number below 22.5, let's use 22. Let's use a number, well, let's then use 22.5, and a number above 22.5, 23. I like to keep life easy by picking whole numbers. And if we plug this into a calculator, so plug 22 into the differential, we'll notice it does in fact come out to be a positive number, so I'll just write positive, hence it's going to be a rising gradient. Plug in 22.5, it works out to be 0, which is what we were hoping for. Turns out to be like that, and if we plug in 23, it's a negative gradient, which will look like that, and lo and behold, we have ourselves a maximum turning point. Sometimes in questions, they actually say give the maximum area, but occasionally they'll mention that you need to justify the maximum area, or show. Now, your justification is in fact this table here, the nature table. So you can then just go, therefore, x equals 22.5 meters is a maximum area. Or gives a maximum area, sorry, I should really say, because now we need to actually find what that maximum area is. Well, how do we do that? Well, we take the 22.5 and sub it back into our original equation here, which is a of x equals 240x minus 16 thirds x squared. So let's go ahead and do that. So the area when x is 22.5 will actually be 240 times 22.5 minus, oops, I'm running out of space here, 16 thirds times 22.5 squared. And if we pop all that into a calculator, the area when x is 22.5 works out to be a nice and easy, I've got it written down here. There we go, 2,700 meters. And that's it. It's as simple as that. Thanks very much.